I will tell you that I normally do this presentation in like 75 to 90 minutes. They asked me to shrink it down to 50, so we will probably spend most of the time in Management Studio with a demo. And that looks really big to me. I don't want that. I want this. And before I get started, I want you to look at this screen real quick, because this is going to be part of the demo at the end. This is a database that I have. I have a 2019 box running in Azure, and I ran a transaction, and that transaction ran for 241 minutes. Obviously, I could not do that in the 50-minute window, so you have to trust me that it was 241 minutes. Essentially, I just created a table, inserted a bunch of values, but I'm going to actually roll this thing back, and this database does not have ADR enabled. So right now, this database is functioning like you don't have ADR turned on, you're not on 2019, what have you, okay? So I'm going to roll this sucker back. And for those experienced DBAs, how long is that going to take? As long as it takes. My buddy Anthony in the back. As long as it takes. So that is running. Yes, we all agree. We can see executing query down there. Everything's running. Yeah. Even on my Mac, Zoom it should work. It does. That query is running. And I apparently need to install some updates. So we are, and I don't have my clicker. I am discombobulated today. We are going to talk about soaring to new heights with accelerated database recovery. This is me. I am John Morehouse. I am a principal consultant with Denny Cherry Associates. If you see me present before, I always give out my email address. You are welcome to email me anything about today. Or if you have any SQL Server problems in your environment, I'm happy to try to help within reason. If I don't know the answer to your problem, I can probably at least point you in the right direction, but I'm happy to do so. I am on Twitter. Actually, I guess it's X now. As SQL Russ. I'm sorry, SQL RUS. It's not SQL Russ, it's SQL RUS. I do blog. Well, COVID kind of killed my blogging mojo, but I do have blogs out there on SQLRUS.com. I'm highly active in the community. I'm an MVP, friend of Redgate, VMware expert, all this other stuff. All my presentations are on GitHub. I will also upload them. Mikey's back there taking a picture. If you want, you can go out there and get it. I can't remember if I uploaded the PDF yet, but I will later today if it's not there. And this is kind of what we're going to talk about, and this is the slide deck if you are still trying to take a picture. We're going to talk about what it is and why do we care about it as DBAs and data professionals. We're going to talk about the new components that Microsoft introduced with 2019 in ADR. We're going to go over, probably pretty quickly, how the rollback and recovery process works today without ADR, and then how ADR actually changed that process, because things do change. And then I've got some cool demos. Now, we're going to go pretty deep down into the engine. I don't remember what level I set this at, but normally this is like a 300 or 400 level session. But feel free to ask me questions. I like being interrupted. If I don't know the answer, I will find out the answer for you and get back to you. And then I've got some time for Q&A, hopefully. So really, what is it? This is the official Microsoft verbiage. Accelerated database recovery improves database availability, especially in the presence of long-running transactions by redesigning the SQL database engine recovery process. That almost puts me to sleep, right? Really, why do we care about it? Because we all know of this person. How many of us have run a transaction in your production environment and then got up and gone to lunch without committing or rolling it back? More people usually raise their hands, or you're just too scared to. I have done this. We actually, in true story, we had a client call us probably a month or so ago now, maybe a little bit longer, in a panic. They're running 2019, but they don't have ADR enabled. They had run a transaction to modify data for 7 days on their production box. One of their teammates goes into the server room, decides to patch the production box. And after you patch SQL, what's it wanting you to do? It restarts it for you when it patches it, right? They patched the box. SQL comes back online. How long is that recovery going to take? About 7 days. They called us in a panic, said, what can you do? There's not much you can do. Once you're in that rollback process, rebooting the box is actually the worst thing you can do because that database entirely is going to be taken offline. If they had just let the transaction roll back by itself, just the affected tables would be blocked and whatnot, right? But we've all seen this person or been this person. What it really gives us is a faster and more consistent database recovery. So we can actually bring our databases online faster, not only through a restart or canceling the transaction. So we can actually bring the database back online significantly faster. Microsoft will tell you it's instantaneous. It's really not. Now, I will give them credit that you can roll back a transaction in less than a second. Another true story. I have a client in Azure SQL Database. They gave me some scripts to run. They told me developers were going to tell me it was going to be quick. That's never the case. They had ADR turned on. It ran the query. 45 minutes later, that query's still running. Their definition of quick and mine are different, right? I canceled that transaction. The database came back online in less than a second, right? Because ADR facilitated that. Through ADR, we also get excessive log truncation. Has anybody run a very large DML statement and you can just watch your log file grow and continue to grow, and then it gets close to consuming the disk space, and you're like, please finish, please finish. ADR actually gives us a tool to help truncate that log more aggressively, so we get less concerned with that. One of the beauty things about ADR, it's available in standard. So if you're running standard edition 2019 or higher, you can turn this on. Microsoft was very, very smart in doing this because it makes things significantly easier for database professionals. The other beauty, it's defaulted in Azure SQL Database and Managed Instance. You can't even turn it off. If you try to turn it off, you get an error. So you can't even turn it off. So if that speaks to the confidence that Microsoft has for this technology, if you are running Azure SQL Database or Managed Instance today, you are already using this technology when you do data modification statements and queries, right? So for those of you that are running it on premises, if you haven't turned it on enough or already, this should be one of those pushing points that Microsoft says absolutely use it. There's a few edge cases where you might not, and we'll talk about that at the end, but this ought to be, hey, we should pay attention to that. Yes, sir?
For older managed instances, would they switch it on?
And the question was for older managed instances, should it be on? Yes.
Is it on by, you say it's on by default?
Yep.
By an old managed instance, is it now also on?
So that's a good question. And follow-up is, if you have an older managed instance, should it be on? Yes, it should. There is a concept of a new wave. There's two tiers of managed instance. You can create a new instance where you don't get updates for SQL versus you continuously stay updated. So you should have it turned on. This is a database scoped property, so you can actually go check your databases to make sure that it's enabled. So yes, unless there's some strange edge case, it should be enabled. So let's talk about some of the new components, right? I think this is all really cool stuff. One of the new components we have is what's called an S-log. So that's a new log mechanism that they introduced. We have a new thing called the persisted version store, and we're going to talk about that. We're going to talk about a thing called logical revert, and that's kind of where all the magic happens, is in the logical revert. We're going to talk briefly about the aborted transaction map and what it's used for, and then we're going to talk about the cleaner and what it's there for and how we can use it. So first, let's talk about the S-log. So the S-log is an in-memory object. There is at the very end, I actually have let's see, it'll just drop down there. I should put that first. If you've ever used function dblog to interrogate your log file, they introduced a new one called dbslog that you can kind of interrogate and see what's going on. It is an in-memory object, so it's not like I can select star from that table or whatnot and actually see the contents of it. The only way I can find to actually see what's in there is in that function. And that object is what contains all of our non-versioned operations. So when we modify data, SQL Server has a certain number of operations that it takes that are non-versioned. Most of those, think of those as like the locks, right? SQL Server is a pessimistic locking beast where it wants to lock everything down to make sure that things are modified correctly and isolated. Those locks are non-versioned, and it stores those locks in the S log instead of your transaction log, okay? So it actually moves it around. Yes, sir?
Question on mine.
Yes, sir.
Does it work with databases with pre-2019 compatibility mode set?
So the question is, does this work for databases without 2019 compatibility level set? And I think the answer is yes. That's an engine level feature. I think that is correct. And so we're removing components out of the transaction log into the S log, right? And because it's in memory, when we have to read from that new object in a crash recovery or rollback, it's significantly faster. The checkpoints are still persisted to disk, so even though it's in memory, when a checkpoint happens, it still flushes that down to disk, right? And the S log is what allows us to provide that aggressive log truncation, so we don't have to worry so much about the transaction log hitting up against the consuming all the disk space, okay? And I already talked about the system function. I have messed around with the system function. I haven't found it to be very useful yet, but your mileage may vary. If you're totally into the internals, you're welcome to go see what we can find. Persistent version store. Who has turned on read committed snapshot isolation? A few people. Okay. If you've ever gone to my colleague's Monica's session about TempDB and or her precons, she talks quite a bit about read committed snapshot isolation. For those that don't know, read committed snapshot isolation allows readers to not block writers and writers to not block readers. That functions because when you turn that feature on, it puts a 14-byte pointer on every row, and every committed version of that row lives in TempDB in an object called the version store. When your queries come in to read that data, SQL Server says, nope, you can go to the version store to find that data, right? The persisted version store is the exact same thing. What Microsoft did is actually took it out of TempDB and slapped it into the user database. So it's the exact same version store that read committed snapshot isolation uses, right? So if you have that already turned on, and then you go turn on ADR, SQL Server will just yank your version store for your database out of TempDB and put it into that user database, okay? It's the exact same construct. The version store actually stores off-row versions of your data. That's why it's called the version store, because we're going to store multiple versions of your data. Now, what does that mean from a database size? So what happens if you enable read committed snapshot isolation? What's that do to your TempDB? It potentially makes it bigger, right? If you've got 500 databases on your SQL instance and you turn on read committed snapshot isolation for all of them, now we're storing a bunch of versions in TempDB. Now we turn this on, and now we're moving that version store into your user database. Will you see your user database grow? Yes. How much? No clue. It all depends on how much data you have and how much data churn you keep. Right? If you churn through data like clockwork, your version store can grow, and your database will grow along with it. So just keep that in mind, too. When you go to enable this, you probably should monitor for database growth and anything that's out of whack, right? The other beauty I love about ADR, it's AG aware. Who's using availability groups? Oh, good, a good number of you. Okay, cool. Because we can get faster recovery when like SQL Server goes through crash recovery or a restart, if this thing is AG aware, does this make your failovers faster or slower? Faster. Because when you do a failover in SQL Server in an AG, it has to go through crash recovery on your new primary. It has to go through the exact same process, it's the exact same thing as you do a restart. It has to go through the analysis, it goes to the rollback, and does the redo. Right? So if this makes all of that faster, you actually can fail over faster. Has anybody ever tried to fail over when you have a very large redo queue? It sucks. You get to click that failover button, you just sit there and, hey, we're just gonna wait, right? I love that this is AG aware. And that is part because the version store was moved out of TempDB. If Microsoft hadn't moved it out of TempDB, we'd be stuck, right? But every time that we touch the persistent version store, that's replicated to our secondaries right along with it, right? I think it's a work of beauty. Logical revert. We also have another concept of an in-row version. I had mentioned that the persisted version stores the off-row version. They introduced a new idea called the in-row version. And essentially what that means is that if your data change is small enough, SQL Server will actually retain the version of your data in the row on the page. There is a size limit there, right? SQL Server works in an 8K page size, and that's finite. You can't change that. Think of a piece of paper, right? So if your data change is small enough and SQL Server can squeak it in there, that that change will live on that page in that row, right? If you undo that change though, that version will stay there. This logical revert will come around later and undo it. That's one of the magic pieces that allows us to bring the databases online faster. It's asynchronous in nature, which means that you can do the rollback, and then SQL Server is going to do all this behind the scenes while you just carry on and keep going, okay? It does keep track of all the aborted transactions for us, and it actually works with the aborted transaction map. This is the other key. Anybody who has done a long-running transaction and then clicks rollback, the reason it takes forever to do the rollback is not only does it have to go through, or I'm sorry, let me rephrase that. The reason you are blocked until that's done, in the old school method, SQL Server keeps the locks on all tables and rows that it touched until you are done. So until you either commit it, and then the locks are gone. If you roll it back in the old school, those locks stay there. That's why you are blocked. Once the rollback has done all the work and undo all the data changes, then the locks are released, and then you can access your tables, and only then. With the logical revert, SQL Server actually releases all the locks immediately after you click rollback. So as soon as you click rollback, all those locks go away, and your objects come online. Right? The logical revert helps facilitate that. Aborted transaction map, it's not a bank. I thought that was funny. That was just it's not that ATM. So now we have a new concept called an aborted transaction map. SQL Server uses a number of different maps to keep track of things. There's an index allocation map. There's a SCAM, which is a shared allocation map or a global allocation map. It's all about keeping track of what pages and rows have aborted transactions on them. So even if we have an in-row version of a data change, SQL Server keeps track of which transaction made that change and whether or not it was aborted. If it wasn't aborted, it's not in this map, right? Would you play around with this as a DBA? Probably not. I do because I'm a nerd and I stay up till 10 o'clock at night on Saturdays because I don't have a social life messing around with this stuff, right? It's implemented as a hash table. You can see some DMV stuff. There are some new DMVs that you can go poke around somewhat on this stuff, but the map itself is a hash table. You can't really interrogate it like a table. The rows are linked to the persistent version store, and we can see this in extended events. If you like messing around with extended events, we did get some new extended events with ADR that you can go see. And there's the DMV. So there's a sysdem tran aborted transactions that you can go see, that they extract that out of the hash table for us. The cleaner, I love this kid. He's a cute kid, cleaning the streets. The cleaner removes the versions that aren't needed, right? So anybody ever hear the ghost record cleanup? Yeah. So if you delete data in SQL Server, the data is actually not deleted. Behind the scenes, there's a metadata operation called the ghost record cleanup. That ghost record cleanup will come around after the fact and clean up your data, right? You can turn that cleaner off. I wouldn't advise it. Don't ever do that. Do not turn off the ghost record cleanup and say that John did it, because that's not true. This cleaner does the same thing. So when you make data changes and you abort that, or there's old versions that are no longer needed in the persistent version store, this cleaner will spin up and then come through the version store and clean things up, as well as on the page, right? The trick is that it is asynchronous. The problem is that it has really crappy thread architecture unless you're in 2022. In SQL Server 2019, there is a single thread for the cleaner for all databases. That sucks. It really sucks, right? And that's at the very end. If you have a very highly volatile workload, ADR might not keep up. Not because it can't keep track of the changes, the cleaner can't keep up. That's the one downside. In 2022, they significantly improved that, where each database has its own pool of cleaner threads. So they actually changed that in 2022. So if you're in 2022, you're in a better spot, right? You can't disable this cleaner. And you can force a synchronous persistent version store cleanup if you want. I've never run across anything that has made me do that, but it is there. What do I go to? 3? Yeah? Okay. Cool. ADR configurations, there are some new configuration values. If you do a select star from sys.configurations, we can mess around with some of the ADR settings. You can actually adjust the cleaner retry timeout. So the cleaner, because it's asynchronous, if it can't get a lock to clean things up, it will bail out and then come back later and try it again, right? You can adjust those retry timeout values if you wanted to. I'm not sure that I would unless I was under the guidance of like Microsoft support, okay? You can also adjust the ADR pre-allocation factor. And what that really refers to is, because we have this new concept of the persistent version store, Microsoft will allocate pages for the persistent version store in a certain amount. Usually it's like 8 pages at a time, right? It's an extent, okay? You can change that if you have a highly busy system. You can change the allocation factor so that SQL Server will allocate pages at a bigger volume instead of, because every time it allocates pages, you have to wait, right? Because if SQL Server needs to write pages to it and it doesn't have pages, it has to allocate it, let you write, allocate, let you write, okay? You can change that factor. The big star at the end, I wouldn't do that unless Microsoft support told me to. We had a client that they had a 18 terabyte database, super busy financial organization in the United States. They did not have this turned on, and they're the one client that I was like, I might not turn it on. We turned it on anyway, and they were fine. We didn't adjust any of this information. We didn't adjust any of these configurations, and they were hunky-dory without a problem, okay? Their AGs failed over faster, I'll tell you that. Yes, sir? So the question is, once the page is allocated to ADR, or the persistent version store, does it stay there or is it ever deallocated? I don't know the answer to that question. I think it's there. I don't know that that page is ever deallocated.
If you do have to wait, you'll only have to wait that first time while it's growing, won't you?
That's possible, yeah. Yeah, I'm not sure I know the answer fully for that question. Good question, though. If you give me like half a day, I'll find out for you. Cool. How do you enable it? It does require an exclusive access, right? Just like it's an alter database statement, you have to get access to that database to make that change, right? You can put your version store in a different file group. That was something that changed from the initial release. So in subsequent CUs and whatnot, Microsoft actually updated this so that you could put the version store somewhere else if you really wanted to. I typically don't. I leave it in primary because I think it's a system level thing for the database, and so I like to keep all that together. But if you choose to do so, you can put it elsewhere. Okay, all good on the components. That was all of them. Yeah, okay. So let's talk real quick, rollback. Very common image from Microsoft Docs, right? This is without ADR enabled, right? So anytime we do a rollback, crash recovery, failover, what have you, SQL Server has to go through these steps. The first one is analysis. From the last checkpoint to the end of the log, SQL Server will read that file to figure out what it has to do and what transactions it has to roll back and roll forward. Once it's done the analysis phase, it goes all the way back to the oldest transaction. Think about my client 7 days. SQL Server had to go back 7 days worth of work at the very end and replay all of those for 7 days. It's called the redo. So SQL Server will redo all of that work. Once it gets down to the end of the log of the redo, then it says, what wasn't committed? I have to undo that all the way back to that 7 days. Typically, we will say that the rollback process is going to be proportional to the running of the length of the original transaction. I've actually seen it be twice as long, right? So my client, thankfully that client, it came on within a couple days, but it could have been 14 days, right? Because it's got to be 7 days to do the redo and 7 days to undo it, depending on whatever, where they were at, right? So this is very typical in situations where you don't have ADR enabled. With ADR enabled, we still have the same kind of format, but we have our new components involved. So like phase 1, we still do. So SQL Server still does phase 1. We do the analysis from the last checkpoint to the end of the log, but phase 2 is different. You can see there it starts doing the redo from the S log first, so it applies all the locks. And because locking mechanisms are really, really small, it can happen really, really fast, right? So it redoes the non-versioned operations, and then from the last checkpoint, it'll do the normal redo phase and redo those transactions. Once it's done with phase 2, it does the exact reverse, but it only undoes the S-log stuff. We actually don't have to redo all the uncommitted stuff from the transaction log, okay? One of the reasons that we can come online a lot faster. Because remember, as soon as I clicked undo, all my locks are gone. Now, normally I would do a demo of that locking mechanism. I don't have time today, but if you want to see it, I'd be happy to show you the locking where it unlocks in the transaction log. You can actually see it. They actually moved it in the chain. Okay, any questions? Sweet. Let us go play around. Okay, can everybody see that okay? Is that size-wise good for the people in the back? Good? Okay, if not, let me know. So over here, I have a couple, this is the same box. You'll notice that this is the query that I rolled back before I started. You'll also notice that it's still going, right? I have a database. It's called ADR. I have ADR turned on. I'm going to look at the pages that are in the database, and I have a single table. It's a single table called people. It has one row in it. It has an ID field and a first name and last name. And right now it is set to John and Morehouse. And we're going to make some changes. We're going to make some changes to this data, and then we're going to see how ADR works. We are looking at a number of different pages. We will see that this particular table, we can see that here's my table on the right. I have 9 rows, right? We can see right here we have 9 rows, which is expected because by default in 2019, actually 2016 and higher, SQL Server allocates 8 pages for every allocation. It's called a dedicated extent. And there's 1 page for an index allocation map, so I have 9, and that works. My first page that I need to pay attention to, and I love Microsoft's naming convention sometimes, the allocated page ID. That's a great naming convention. The page that we're going to function on or work on is 336. So everybody remember that number, 336, because we're going to use that quite a bit. Okay, so we know what number we're going to look at. This is what the current structure of the page looks like. So, sorry. From a page construction standpoint, the data page itself is for the most part the same. This all looks fairly normal. If you've ever looked at a data page within SQL Server, it has a header, it's got some data in it. It'll tell you a number of different things, like what object it belongs to, how many pages or how many records. If you see that M slot count equal 1, it means I've got 1 row on the page. It tells me the next page, how free it is, how many ghost records I have on the page. In this case, I don't have any because I've only got 1 row. So this all looks fairly normal. If we scroll a little bit further down, we can actually see I've got some record attributes, a null bitmap, variable columns, but we can actually see my data, right? We all agree, we can see John Morehouse there, right? If you reversed engineer the hexadecimal over there, we know that that'll say John Morehouse. The 77365 in the hex should be the S and the E in my last name. Who's got a hexadecimal editor fired up? Nobody? Oh, really? I'm not a robot. Oh, really? Holy smokes. Watch, I'm going to fail it. Oh, my gosh. Okay, somebody fire up a hexadecimal editor. We're gonna keep going. Or you just trust me. The 7365 is the S and the E in my last name, okay? And that'll come into play later, too. We also have some other information down below about the slots. We can see the offset, we can see the length, we can see a bunch of different other stuff. If I go and start making changes to it, things get interesting. So we're going to change some data. I'm going to do a checkpoint, I'm going to start a transaction, and I'm going to update a row, the only row. And I'm going to update the row to set the first name to Duke. I lost my father to COVID in 2021, and they say that people die twice. They die physically the first time, and they die when people don't say their names anymore. So I use this session to keep his names going. So I updated the page. Let's take a look at the page. Whoops. If we scroll down, page header all looks, for the most part, pretty much the same. Nothing has really changed. We haven't changed objects or anything. However, what's different, what's new here? We have this new attribute called versioning info. This wasn't here before the change. So this tells SQL Server that data has changed and we've done something to that row and or that page. What else do we see here? We now see I have an in-row version. So here's my dad's name, Duke Morehouse. I did change the first name, but because my data change was small enough, SQL Server could put the old version of that name into the row itself. So it doesn't live, technically it does live in the transaction log, still somewhere, but right now I've got a version of that data change in the row, okay? Right, we all agree? We can see that data change? Cool. The big font is throwing me off. So let's go look at the version store. We can interrogate the version store. The version store will actually tell us like how many rows are in the version store, how big is the version of the row store. Well, so if we look at this data, oh crap, 15 minutes. Ooh. I've got one page, so I've got one page allocated for the version store. I have one in-row version record, which is true because we proved it. We looked at the data page, that version of the data was in the row, wasn't in the version store itself. If we scroll over a little bit more to the right, I have 0 off-row version counts, which means that I haven't made a data modification big enough for SQL Server to say it won't fit on the page or the row, push it to the version store. So let's go do that. So, and notice I haven't committed anything. So I'm in the same transaction, right? I haven't rolled it back, I haven't committed anything. So let's make another update. So I want to update that same row. I want to change the word Duke to Pete. So I actually lost this is my uncle, my dad's brother. I lost him 2 months before I lost my father, also to COVID. So again, I'm going to say his name so that his name carries on. So I've successfully updated the page, right? I affected that row. If we now look at the page, whoops, scroll up, come on, my mouse is not working. Scroll down, scroll down, scroll down. Whoops. We can see Uncle Pete, his name is there, so Pete Morehouse is there, but Duke and John are gone. I've now pushed enough data, made a big enough data change where SQL Server has now pushed that to the version store, right? And we can go a little bit further if I had more time. You can actually reverse engineer the transaction timestamp, the page ID, and the slot ID if you're really bored. You can actually reverse engineer that and tie that back to the version store because it's all interconnected. So SQL Server actually uses the version pointer as to where it lives in the persisted version store. So you can actually reverse engineer some of that. Right? So let's go look at the version store then. Because we should have pushed that data into the version store, right? It's not there anymore. So I still have one page count. I have one version record count. You'll notice, though, my in-row version count decreased by 1, right? And that lines up. We didn't see the versions in the row anymore. They're gone. They disappeared. But if I scroll over, my off-row version count increased by 1. So now my version of my data has changed. The other thing that has changed, and I can try to see if I can get to it in time. Dun, dun, dun. Let's see if it's in here. Did anybody remember the timestamp number that was on the data page? Anybody remember it? I'm pretty sure it was 6245, right? This is the version store. So now you can see on the bottom of the page, the data page, that number. Let's go back up, let's go check. I need like a much bigger monitor. Oh, 6245, right? I was right. So if we go back and look at the version store, which is the off-row versions, 6245. So now we've linked the data page to the version store, right? If we were to reverse engineer some of this stuff and do some math, we can do more with it. But we can see some information, like here's the actual row versions. If I had the ability to actually deconstruct this binary, it's going to tell me Duke and John, right? Because I started with the name John, changed it to Duke, though my row version is in there. Now, the other thing that you'll notice, this is the entire row, not just my data changes. Because the version store, just like with read committed snapshot isolation, retains the entire version of the row, not just what you changed. Even though I changed one component of the row, the persistent version store is going to have the entire row because read committed snapshot isolation needs the entire row, right? So this would have the ID, the first name, last name, the whole gambit. 10 minutes, sweet. Cool. With me? Everybody good? All right. Let's see what's next. So I'm going to roll that back. Let's see what else am I doing. So now all my changes are, well, let's do this. You'll have to trust me. You can see all the information in the extended event session. I do have an extended event session stood up. If you want to see the extended events, come find me afterwards. For timing purposes, I want to move on to the grand finale probably. So, any questions before I do the grand finale? Yes, sir. Yes, I'll get to that in like 5 minutes. Got some slides. Anybody else? Okay. That's how ADR works. If your data changes are small enough, SQL Server will store that version in the row. If it's too big, it's going to go to the version store. Okay? You saw me before I even started the presentation. I had this transaction in the old school method. It is still running. It has been running for 39 minutes, almost 40. I fully expect that transaction, like I can't do anything to this box until it's done. Because if I restart this box, what's it going to do? It's going right back through crash recovery. I got to start over. This thing is going to run for about 4 hours later today until I come back to it, and then I know that the rollback is finished. Technically, I could stop it and like delete the database and do some other stuff. That's just a pain in the ass, right? We all agree that's running, right? We've all seen that. I did the exact same thing on a database that has ADR enabled. We can see that it ran. It did the work for 197 minutes. It's a little bit faster than the other box, but I was also running these concurrently on the same box, right? The log file on the other one is like 200 gigs, right? So what is the expectation if I roll this sucker back? Any bets on how long it'll take for that to roll back? Sub-second. Anybody else? Do you want to see the magic? Yes? You got it? I am online. I can go to the database. It didn't even measure anything less than a second. My database is 100% online. My table is online. I can go do stuff with it, whatever. That took less than a second. That transaction ran for 197 minutes. I rolled it back in less than a second. This is one of those game changers that Microsoft has introduced into 2019. If you are not on 2019 or higher, if you are trying to convince management why you should upgrade, this is one of those reasons. Because as a DBA, I have been in multiple, I can't even count on my hands and feet how many times I've been involved with somebody who has run a transaction, long running, forgot to commit it, forgot to roll it back, and it's minutes, hours, days, weeks later, and they're stuck in that rollback process. And without a doubt, some C-level person is going to come across and say, reboot the server. Don't ever reboot the server in that situation. That's the worst thing you can do. Because if you reboot the server, the entire database is going to be offline until it finishes crash recovery. Right? Less than a second to roll back a transaction that took 197 to work. Yes, sir? How does CDC impact ADR? There is no effect to CDC with ADR. So you can enable CDC with ADR just fine. Yep.
Even if you've got like lag on CDC and it's holding certain transactions.
Well, that should be fine too. As far as I know, there's no problem with CDC and ADR. We had a client that we implemented ADR and CDC. Yes, sir.
Page splits and forwarded rows are something you obviously want to avoid. And this, in some kind of way, seems to be similar to forwarded rows. So if you've got too many versions, could you?
Yeah, so the comment is page splits and forwarding records is typically not a bad thing, or I'm sorry, not a good thing. You can incur a different I/O path, right, to do that, and you do have a hit. That same kind of concept, right? SQL Server has to read where that version is and then go fetch it from somewhere else. Yeah, you could see a bit of a tick of an I/O. In our experience, it's not anything that we have said, oh, don't turn this on. But there are times where you probably shouldn't turn it on, and if your application's like super busy, if I can get my mouse to actually work, we will wrap up because I think I'm like 5 minutes left. Yeah. When not to deploy ADR, if you're highly transactional. If you are super, 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 super busy and you are churning data like crazy, ADR might not keep up, especially in 2019 with that single-threaded cleaner. If you're in 2022 and you can have that multi-threaded cleaner, you could probably do better, okay? High volume of data modifications. That's important because if you have to keep track of all those versions, it might not work well, okay? In our experience, most likely it's an edge case. Yes, sir.
Got a question from Stephen online.
Hi, Stephen.
Are we swapping transaction log size for internal recovery log size? I.e., do I need to worry about disk size for data files in massive databases?
So the question is, are we trading log recovery size instead of, like, now we're putting that into the version store and the data file, if I'm paraphrasing his question correctly. We are trading, if you attended Monica and I did a pre-con on Monday, and anything in SQL Server is about balance. You have to balance CPU and memory and storage and disk and everything, right? We are going to take some space out of the transaction log in favor of putting it in the data file. So you might see some trade-off there. How much? I can't tell you. That's going to be a very large, it depends. Thank you. It depends, right? Right. This is where are we all monitoring our systems for diff when things change? Yes. Everybody should be nodding their heads. Yes, we should be watching our databases when they change, right? I've yet to really incur a situation where ADR doesn't make sense. I'm going to tell you, test it. Don't go back to your production environment tomorrow and turn it on and say, John said to turn it on. Go test it, all right? Test your workloads against it to make sure. What do you want? So I think the question was from my good friend Anthony. What kind of pain are you going to feel if you are in this edge case scenario? I think that what you'll feel is you'll feel some I/O pressure. You might not because of who you work for. He works for Pure Storage, which is probably some of the best storage on the market these days. You also might see database bloat because if the cleaner can't keep up, your version store is going to continue to grow, right? So if your version store is going to continue to grow and you can't mitigate that, you have a storage capacity problem that could balloon out. But I have yet to see, as I mentioned, I had a client, very busy system, very large database, what I think is a relatively large, 18 terabytes. We turned it on and it was hunky-dory. They did fail over faster. Yes, sir. It depends. I can't. I don't. You would have to determine whether or not your system is, again, our client was a financial institution. I mean, thousands and thousands of transactions a second. They were busy. I don't remember exactly what their metric was, but they were busy. Probably one of the most busiest clients I've ever had. It was one of those systems where if we sneezed wrong, their system had a problem, and we turned it on anyways because they actually were having problems with their availability groups, and this actually helped them fail over faster. That was one of them. I think it would be fine, but I can't give you a guarantee because you're going to come back next week and be like, John, you lied. So I think so, but again, test it. Test anything you hear today, go test. Please, for the love of God, go test things before you put it into production, okay? So test it.
Is it high transactional and high volume, or one or the other that you don't recommend?
Say that again, I'm sorry.
Is it high transactional and high volume of data modification?
It could be both. Could be one or the other. Yeah. Yeah. Usually more of the data modifications because the version store is not going to come into play unless it's modifying data, right? There are tools to monitor the version store for size growth and stuff, so you can go out there and monitor it on a routine basis. Most modern monitoring tools, like
Redgate, Idera, Sentry. I think they all have hooks into the version store. So if you are on 2019, you have one of those tools, Foglight, Spotlight, whatever, they might have components, widgets to allow you to monitor that. So in summary, we get faster rollbacks. I'm happier as a DBA because I can roll back stuff faster. I get faster crash recovery when we start up SQL Server or do a failover. If I can do a failover and stay online faster, especially with a multi-terabyte database, my clients are significantly happier, right? I get my aggressive log truncation. I still have to worry about the log bloating out the disk, but I worry about it less, okay? Enable it for the majority of the use cases. It's relatively simple to enable, and it's simple to undo it too. Just undo that data change. Here's some resources. If you really can't sleep at night, this white paper is phenomenal. I read it, and Microsoft did a great job in the white paper. I read it literally for like seven nights in a row until it all kind of clicked with me and how they made this magic work, okay? This is a really great white paper. This article on Redgate has fantastic animated graphics that will walk you through it. Also, that stat call resolver, if you're really curious, I have another session where I actually go into a debugger and we actually crack the SQL C+, right? Or C, actually I think it's C. That's a free tool. If you get a stack dump, if you get the call stack, that tool will automatically resolve that call stack to what DLLs is involved in that call stack. It's a free tool. Didn't even know it existed, okay? You can go download that, okay? All right, what questions? I think I'm 2 minutes over, 3 minutes over. You're so close. Questions, answers? Yes, sir.
In another session, I complained about how long a restore takes in SQL Azure or in managed instance, and somebody said, do you have ADR in it? Will that help in
Yeah.
restoring to a
Yep, so this will also help in restores too.
But in a restore, there is a database copy, basically, right?
It does in a database copy, but what happens after the database is restored? It's got to come online. Because a database backup, and the question was, in managed instance, if you do a restore, do you have ADR enabled? And whether or not this will help. So in a restore, it's going to relay, basically it's going to write down all the files, all the pages, and the backup only has a certain amount of the log file, not the entire log file. But if you had ADR in the source and restored it, your persistent version store is going to be included in that backup. It's an object within the data file. It's going to be in the backup, right? And so as soon as it comes online, SQL Server is going to utilize that to help come online faster. Should, unless there's some strange reason going on. Now, if you don't have ADR enabled, SQL Server managed instance will probably enable it after it comes online, because it can't make any changes to that database until it's actually online, right? I like feedback. If you hated the session, totally fine. I'm okay with that. Tell me what you didn't like so I can make it better. If you loved it, give me 5 stars or whatever. For every feedback, I think they're donating to a charity. So I don't care if you give me no feedback, just let them donate to a charity. Let's help other people, right? Ta-da, that's it.